few MCQ question based on the topic radioactivity. In the last class, I explained in detail about. Sorry, I forgot to wear the mic. Yes. Good morning, everyone. Welcome to my class. Today's class, I am going to solve few MCQ question based on the topic radioactivity. Radioactivity MCQ question. I am Sunita madam. Once again, welcome to my class. Okay. Let us discuss the first question. Let us discuss the first question. The loss of one neutron is equivalent to. Yes, where you will find the loss of neutron, whether it will be alpha decay or beta decay or gamma decay. The loss of one neutron is equivalent to increase of one proton, first option. Second option, none of this. Third option, both loss of one alpha particles and increase of one proton, loss of one beta particles. The loss of one neutron, it will be equivalent to, four options are given. Let us discuss the answer. Both loss of one beta particle, increase of one proton. The correct answer for this question is option 3 is the correct answer. Understand the question first. The loss of one neutron. Neutron is neutral. It does not carry any charge. Then here when you will get a loss of neutron. Okay, in which case there will be a loss of neutron, it will occur only in the case of a beta decay. Loss of neutron, you have to remember the atom, it is undergoing a beta decay. When you will consider an atom, when loss of one neutron occurs, then to balance the conservation of energy, it will increase the one proton, because both have to be balanced. Then loss of one neutron, it will be equal to one neutron. It will be equal to beta particles. Sometime in the case of beta decay, the loss of neutron, it will be equal to the loss of beta particles, because beta decay, it will involve the emission of beta particles, otherwise loss of beta particles, correct? No? Therefore, the loss of one neutron, it will be equal to loss of one beta particles. Then here, when one neutron is lost, then to compensate, otherwise to balance the conservation of energy, the system, otherwise the atom, it will increases one proton. Therefore, the correct answer for this question is option 3 is the correct answer. The loss of one neutron is equivalent to both loss of beta particles and increase of one proton. Why in this atom, why it will increase one proton when there will be a loss of one neutron? Because to balance the conservation of energy. Because you know, according to the law of conservation of energy can neither be created nor be destroyed, but you can transfer from one form to another form. Let us move to the next question, easy question. Charge on alpha particles is how many times the charge on a proton? First option 4 times, second option 2 times, third option 3 times, fourth option equal. The charge of alpha particles. Alpha particle is nothing but helium atom. Atomic number is 2. Atomic number is 2. Here we will write the atomic number is 2. Then mass number is 4. Then charge on proton is, once again I will read the question. Charge on alpha particles is how many times more than the charge on proton? How many times? It will be 2 times. Charge on alpha particles is how many times the charge on a proton, means it will be the 2 times, because charge of a proton is plus E, only 1. From its above, charge on alpha particles is plus 2E. Therefore, alpha particles 2 times the charge of a proton. Charge of a proton is E. Okay. Then charge of alpha particles, its atomic number is 2. Therefore, 2E is nothing but 2 times. Therefore, the correct answer for this question is charge on alpha particles is how many times than the charge of a proton. Charge of a proton is E, then charge of alpha particle is 2E, because its atomic number is 2. Therefore, option 2 is the correct answer. Let us discuss one more time what is meant by radioactivity. Quick revise, okay? Radioactivity decay is the process by which unstable atomic nucleus loses energy by radiation. Why the atoms? Why they will occur? Why they have to undergo radioactivity? Because the atoms, some atoms may be unstable. To attain stability, the atoms, they will undergo radioactivity. A material containing unstable nuclei is considered radioactivity. The unstable nucleus is there, no? That one we will call it as a radioactivity. Okay. Let us move to the next point. A radioactive nucleus consists of an unstable assembly of protons and neutrons. Yes. Nucleus contains proton and neutrons. In the radioactive nucleus, it contains unstable assembly, means the protons and neutrons, they will be unstable, which become more stable by emitting alpha, beta and gamma particle. Atoms are radioactive if their nuclei are unstable and spontaneously or randomly emit various particles like alpha, beta, gamma radiation. That radioactive nucleus, the atom, it will undergo radioactivity. That nucleus we will call it as a radioactivity nucleus. Then here 3 crucial forms of radioactivity is there. First one is gamma decay. Photons having high energy are thrown down. In the gamma decay, photons, they will be emitted, they will be released. Photons, they have high energy. Then in the case of a beta decay, discharge consists of an electron. In the beta decay, it will involve emission of an electrons. In alpha decay, even neutrons is sometime it will be converted into proton. Then proton, it will be converted into a neutron. That we will see in the beta decay. But here discharge, it will be consist of an electron. Then alpha decay, discharge consists of helium nucleus. Alpha decay always it will involve the discharge, it will be consist of helium nucleus. Let us compare alpha beta decay, alpha beta gamma rays. Okay, characteristic alpha particles, beta particles, gamma rays. Symbols, alpha we will represent like this, then beta we will represent like this, then here this is the symbol we will use, then this one is the gamma. Identity, helium nucleus normally. Then here in the case of an beta decay, there will be a discharge of electrons. Even neutron sometime is converted into proton. Proton, it will be converted into a neutron. That is beta decay. Then in gamma, electromagnetic radiation. Then charge. Alpha particles have +2 charge. Then beta particles -1. Gamma rays, they will not show any charge. Then mass number is 4. Helium is 4. Then in the beta particle, mass number is 0. In gamma also mass number is 0. Important one you have to remember. Then what is the penetrating power of alpha, beta, gamma rays? In the case of an alpha particle, minimal, will not penetrate the skin. It will not penetrate the skin. Alpha particles, they will not penetrate the skin. Beta particles penetrate skin and some tissues slightly. Penetration, it will be there in the case of a beta particles, but it will be very less. But in the case of gamma rays, deep, will penetrate the tissue deeply. That's why gamma rays we will use to cure the cancerous tissues. Otherwise, to cure the cancer we will use the gamma rays, because gamma rays they can penetrate, they have the capacity to penetrate deeply inside the organ or human body. That is the main important of gamma rays. These are the few important points I given the list. Please revise that one, it will be helpful for you. If they ask any MCQ questions, you may answer. Okay. Next one, a beta particle is same as, now only I told, a beta particle is same as an electron, second option proton, a positron or a neutron. What is the correct answer? Beta particles, it will involve the discharge of an electron, I told. Therefore, a beta particle is same as an electron. That one you have to remember. Next one, consider to the off-life period. Off-life equation of the radioactivity substances. What is the equation? You have to remember the equation, the correct answer for that one. Okay, let us study what is meant by off-life period. Okay. The process of radioactivity decay as a function of time is given by ln n divided by n naught. It will be equal to minus lambda t. Here n is the number of radioactive nuclei present in a sample. N naught is the number of radioactivity nuclei present in the same sample. In the sample at t, it will be 0. T, it will be 0 means at when time is 0, N naught is the number of radioactivity nuclei present in the same sample. Then lambda we will consider as a disintegration constant. This one you have to remember, very important thing. The radioactivity decay, the process of radioactivity decay as a function of time. This one is ln n divided by n naught, it will be equal to minus lambda t. Then here, what is mean by disintegration constant? I told lambda we will consider as a disintegration constant. The disintegration constant is the unique constant related to the radioactive nature of the given nucleus. Thus, that disintegration constant, it will tell the unique constant, that it will be a special constant, otherwise unique constant. It will relate to the radioactive nature of the given nucleus. Whether the sample is highly radioactive, whether it is a less radioactive, whether it is a radioactive or not, everything it will be decided by lambda. That disintegration constant, it will tell the radioactive nature of the given nucleus. That you have to remember. Okay. Then what is mean by off-life period? The time in which the number of nuclei reach to off of its initial value is called as its off-life period. Off-life period, the name itself is indicating off-life period, the time in which the number of nuclei reach to off of its initial value. Okay. If you are having the number of samples n, if it is reached to n by 2, then we will consider it is completed off of the decay. That is nothing but off-life period. Here I wrote n, it will be equal to n naught divided by 2. N naught, here I mentioned n naught is the number of radioactive nuclei present in the sample at time 0. Then here n is the number of radioactive nuclei present in the sample. Okay. Then according to the off-life period, then here substitute here in place of n. In place of n, substitute n naught divided by 2. Then ln n naught divided by 2 divided by n naught. Then n naught, it will get cancelled. Then here you are having minus lambda t is there. Then ln n, it will be equal to minus lambda t. Here we will consider t off, because off of the radioactive decay is completed. That's why we will use the term t off. T off, it will indicate off of the radioactive decay it is completed, because we use the symbol here n naught divided by 2, n it will get cancelled, n naught it will get cancelled. You will get ln 1 by 2 you will get here 1 by 2. Otherwise simply you can use okay, then here 1 by 2 you will get. What is the value of ln 1 by 2? Here you will get the value. Here I wrote here t to the power of 1 minute. Some disturbance is there here. Okay. The off time is given by t of it will be ln 2 divided by ln 2 divided by lambda. Then ln 2 its value is 0.6931. Okay. Then here you will get t of it will be 0.6931 divided by lambda. This is the value t of. Better I will rub this one. Already I wrote here. Already it is there here. Okay. Here n it will get cancelled. Then t of it will be here of 1 by 2. It will be equal to ln 2 divided by lambda. Then what is the value of ln 2? 0.6931 log 2. Okay. T of it will be equal to 0.6931 divided by lambda. Therefore, what is the answer for this question? The off-life equation of the radioactive substance is T of it will be equal to, what is the value here? Lambda. T of it will be equal to 0.6931 divided by lambda. 0.6931 divided by lambda. Confusing here, they are given so many options. Don't get confused. T of it value it will be equal to 0.6931 divided by lambda. What is mean by T of here? Then here T of it will indicate off of the radioactivity decay. Then lambda is the disintegration constant. What is the meaning of this one? Whether that radioactive element, how much it can easily, it will undergo a radioactivity. Whether it is highly radioactive element, whether it is a low radioactive element, everything it will tell. Okay, let us move to the next question. Those who are not able to follow, please see my theory class radioactivity. If you watch that theory class, these questions are very easy. You can answer it very easily. If a uranium-238 nucleus split into two identical parts, the two nuclei so produced will be, first one radioactivity, second option stable, third option isotope, fourth option isobar. When the atoms, when they will undergo radioactivity, when the atoms are unstable, this uranium-238 is unstable nucleus, correct? No, otherwise unstable atom you can consider, otherwise unstable nucleus you can consider. Then once this undergo a radioactivity, whatever the product you will get, that it must be a stable. Very easy question. Yes, correct answer. The next question also very easy. An alpha particle is same as a, first option helium nucleus, second one a hydrogen nucleus, third one a proton, fourth one a positron. No need to waste the time. An alpha particle is a helium nucleus. Easy one, I will go it fast. Okay. Radiocarbon dating technique is used to estimate the age of, first option rocks, second one soil, third one fossils, fourth one buildings. Radiocarbon dating, where we will use this one, radiocarbon dating, where we will use this one. This technique is used to estimate the age of fossils. Remember this one. Okay. Then next one, which electromagnetic wave are mainly used as a treatment for cancer? Easy question. First option alpha rays, second one beta rays, third one X rays, fourth one is gamma rays. Why we will use gamma rays? to treat a cancerous tissues means gamma rays, they have the high penetrating power. They can penetrate through the skin, otherwise they can penetrate easily to the organ, into the organ of an human body. Then easily it can kill the affected tissues. Then we can cure gamma rays. The next question, half-life of a radioactive element is 30 days. Okay. Then the remaining amount after 90 days. Then what is the value? Understand the question here, what is given here. Half-life of a radioactive element is 30 days. Okay, half-life of a radioactive element is 30 days. T off is given. The remaining amount after 90 days. What is the amount after 90 days? Let us see the calculation here. T of it will be equal to 0.693 divided by lambda. Lambda is the decay constant or disintegration constant. Then here T is given, capital T it will be 90 days, small t it will be 30 days. Then the number of off leaves in 90 days, n it will be equal to, you have to remember this formula, n it will be equal to capital T divided by small t. Small t here they are given the off life period. Capital T complete, capital T it will indicate complete radioactivity decay, it will occur, it will take 90 days, but off of the decay it will take 30 days. Therefore total is 90 divided by 30, you will get number of n values, it will be 3. Then you know the formula, n it will be n naught 1 by 2 whole to the power of n, then n it will be n naught 1 by 2, then n value is 3, then you will get n naught 2 cube is nothing but 8. Easy question, you have to remember the formula, then easily you can solve. Then what is the answer for this question is n naught divided by 8. But here you have to remember this formula, number of off lives. How many number of off lives? N. Number of off lives it will be 3. How you can find out the number of off lives? N it will be equal to capital T divided by small t. Capital T it will indicate to complete decay, radioactive decay it will take 90 days. T means off of the decay, it will take 30 days. Okay, substitute, you will get the n value. N is nothing but number of off lives. How many number of off lives? Okay, you will get 3. Then n it will be equal to n naught 1 by 2 whole to the power of n. Then substitute, we don't know the value of n naught, right as it is 1 by 2 whole to the power of q n naught divided by t. Here they are not given the amount of radioactivity decay. Here they are not given the number of radioactive element, but here they are given that decay of the elements, it will complete decay, it will take 90 days. Then off of the decay, it will take 30 days. They are given in the question. Therefore, correct answer for this question is 1 by 8. Interesting questions. Okay, practice. Easy question this one. In the given nuclear reaction, the element X is, this is anti-neutrino, in which case it will come? It will come in beta decay only. Neutrino, anti-neutrino, everything it will come in beta decay. Then here, this is neon 1022. Yes, here you will get one positron. This one is positron. E plus is positron. Then this mu it will indicate this is neutrino. If I write like this one is anti-neutrino. This one E plus is nothing but positron. It contains positive charge. Okay. Then move to the next question. Radioactivity is the characteristic of which of the following? Nucleus, electron, proton, neutron. Yes, in the beginning of the class only I told radioactivity is mainly depend upon the nucleus. It not depend upon any electron, proton, neutron. Yes, radioactivity is mainly depend upon the nucleus, because unstable nucleus only you are converting into a stable nucleus. Only unstable nucleus it will undergo radioactivity. Not all the atoms they are not radioactivity. If the atoms are stable, then why they have to undergo a radioactivity? Only unstable atoms they will undergo radioactivity. Therefore, radioactivity is the characteristic of the nucleus. Next question, maybe last question, this one. Yes. The radioactivity decay, which of the following quantity depend upon the number of atoms? Half life, mean life, third one rate of decay or rate of decay, and mean life, rate of decay. Yes. Once again I will read the question. In radioactivity decay, which of the following quantity depends upon the number of atoms? The number of atoms, it will be depends upon the rate of decay. Yes, mainly the rate of decay, it will be depend upon the number of atoms, vice versa, both. Okay, thank you everyone. Thanks for listening my class. I don't know why so many students they are not able to watch my videos. Please watch my videos. Definitely it will help to your upcoming exam. Whenever you will get the free time, watch my video. That's why whenever I am having the free time, I am doing my videos, then I am posting. Whenever you will get a free time, please watch my video. Maybe upcoming exam it will be helpful for you. Okay, thank you everyone. Thanks for listening my class. Okay, almost whatever the physics chapters, almost everything, all the chapters I completed. One more MCQ I will do based on the nuclear reaction. Then after that I will take only the maths classes. Okay, thank you everyone. Thanks.